Okay, welcome back yet again to another edition of our teaching and learning series. I believe you've enjoyed all the previous ones we had before. And today we're going to look at something that is a little bit different from what we've been looking at. Though I believe you already have an idea from what you studied in primary. So I'm just going to add to the knowledge you already had or the knowledge you already acquired while still in primary. So today we're going to look at a new topic, and that topic is what we call lines. So we're looking at a topic called lines, and in simple terms, we define a line to be a set of points. In other words, a line is defined to be a set of points. Now, in mathematics, we always assume that a line extends endlessly. In other words, it extends forever in both directions. For example, if I have my line such as this, in mathematics, we assume that this line is going to extend up to this side endlessly. Even this one is going to extend this side forever. So that is the assumption we make when we are looking at lines in mathematics. And we can describe a line using its equation. There are very many different kinds of equations of lines. We have what we call the linear equations, we have what we call quadratic equations of lines, cubic equations of lines, but at this level we are going to look at only the linear equations of lines. Now, we said we can describe a line using its equation. There are very many equations of lines. For example, I can have an equation such as x is equal to 4, or maybe y is equal to negative 2, or maybe y is equal to x minus 2. All these can be used to describe different equations of lines. Now this is an equation x is equal to 4, and this is a line where all the x coordinates are 4. And this is a line where all the y coordinates are negative 2. And this is also a line whereby the y coordinate is gotten by subtracting 2 from the x coordinate. So we're going to look at all that and get to know how do we manipulate around these equations, how do we work out all these different things to get to know about the different equations of various lines. Now, the equations simply describe the relationship between the coordinates of the points that lie on that line. I repeat, the equation of that given line, for example now like y is equal to x minus 2. It defines the relationship of the coordinates which lie on that given line. Now, I believe you already studied about coordinates, and in coordinate system, we're looking at, of course we know that a coordinate has two points, the x point and the y point. So a coordinate consists of 2 points. So the equation of the line just gives a relationship between the coordinates which are contained on that line. Like I already said, for example, an equation x is equal to 4, it just gives us, it is a set of all points whose x coordinate is equal to 4. Now maybe we can look at a few examples to enable us to know how to determine the different types of lines. For example, I can have my examples here. My example 1 to be, if I have points such as 0, 1, I have 2, 1, I have 3, 1, I have 10, 1. Then I also have example 2. This is negative 2, negative 1. I also have another point given as negative 4, negative 1. I also have 5, 1. I also have 10, 1. Thirdly, I can have negative 3, 2, negative 3, 4, negative 3, 5. So I have these equations and I'm required to determine the equation of the lines which join all these points. For example, in example number 1, I'm required to find the equation of that line which joins this point to this point to this point to this point. Same applies to example 2 and example 3. So we're going to look for the different equations of the lines which enable us to fix all these points. For example, now, like these are the solutions, these examples. Starting with the first example, when you look at this example, you have 0, 1, 2, 1, 3, 1, 10, 1. Now, when you look closely, you realize that, remember we talked about coordinates, and the coordinates, we have the x-coordinate and the y-coordinate. The x-coordinate is the one which comes first. For example, in this case, 0 is the x-coordinate, 1 is the y-coordinate. In this case, 2 is the x-coordinate, and 1 is the y-coordinate. Here, 3 is the x-coordinate, 1 is the y-coordinate, 10 is the x-coordinate, 1 is the y-coordinate. Now, when you observe from this line, you realize that all the y-coordinates in this case are 1. I have a 1 as my y here, 1 as my y, 1 as my y, 1 as my y. So, when you find that all the coordinates, for example for y, are all the same, now, my line in that case is simply going to be y is equal to 1. Because we have realized that all the y coordinates in these points are 1. So the equation of the line that joins all these points is the equation y is equal to 1. We can look at example 2. We have -2, we have -1, -2, -1. This is my x, this is my y. This is my x, this is my y, this is my x, this is my y. I made a mistake, should be -1 here, -1 here. Now when you observe closely here, you realize that all the y coordinates in this case are -1, the y coordinates. So the equation that joins all these 4 points is going to be y is equal to -1. Reason being, all the y coordinates in this case are -1. I can proceed to example 3. I have -3, 2, -3, 4, -3, 5. Now, you realize that there is a slight difference from what we had in this case. In the first 2 examples, we had that the y coordinate is the one which was the same throughout. When you come to example number 3, we realize that it is the x coordinate which is common all through. And here I have my x coordinate as -3. Same applies to here, I have my x coordinate as -3. Even here, -3. So the equation of the line that joins this and this and this is going to be x is equal to -3. Because all my x values are -3.